Okay, so we've got C1V1 equals C2V2, and I just want to talk a little bit about setting up dilution tables in terms of, I mean, everything is in proportion. So for last week, for example, C1 was 2000, so I mean that value was our stock solution, so that's always going to be the same. And then we were given a range to work with C2, and actually a range that really works well is where you double the value. So we were told to start at 50. So with concentration, it's good to work with doubles, and that's what I want to demonstrate. The process of either doubling or halving a number to get your progression of dilution. So 50 doubled would be 100. Then we went to 200, and then we went to 400, and we had to go up to 1,000. So we actually ended up with those dilutions. So this is really our starting point. And the first thing I'm suggesting is, it seems to me that a progression that involves doubling numbers works really well, and the glassware is manufactured with that in mind. And then, for example, the thing is to hit on or find some sweet spot in the dilution, and you can build everything from there. So for example, let's say we've figured out that we can go with the 10 and 200, so that would be 10, and that gave us 100 for V2. So let's say we figured out this line, and we can check here. So 200 times 100, there are 4 zeros, and 10 times 2000, there are 4 zeros, so that is equivalent, C1 V1, C2 V2. Now, the thing about dilution tables is we're going to half concentration here, and we're going to double concentration there. So to get from here to here, we've got two options. It's half the concentration, so if I use half 10, I'll get the result there. So just by seeing this as a 10, I know if I write a 5 there, and I write the same number here, so half the initial volume that goes into the solution will give me half the concentration. Or I can double the volume. So I've got two options here to get from 200 to 100, which is half of 200. I can either double the volume, that get the DI water, or the volume that we're making up the solution to, or I can halve the pipette size of the input solution. So we've got two options there. We can either go to 5 here, or we can go up to 200 here. Now, in the spirit of less waste, I'm going to opt to reduce this one by 5 and just copy this number up. So that'll be 100 the same. All we've done here is halve the amount going in, and that's going to give me my half. Now, once again, to go from 100 to 50, it's another half. So my options would be to go to 2.5 here. Well, that's not really practical because we don't have a 2.5. However, I could go to a 50 here, and that, no, I'd have to go to 200. I have to double the volume to get to half the concentration, because the extra volume is just the DI water or whatever matrix solution you're using. So I'm going to choose here, instead of 100, just to write 200. That's going to give me half the concentration now. And of course I can just copy that number up. So it doesn't have to be a whole series of maths calculations every time. You can just use the proportions to build your dilution table. Now, at the start of most of the pracs going forward, you will work in your groups on your own dilution table. So you'll get practice at mastering, I guess, the art of building a dilution table. Now, going up finally to the double concentration again, I either have to double V1, that'll double the concentration, or have to half V2. So I can either write a 50 here and just copy the 10 down, or I can write a 20 here and copy the 100 down. And I'm aware that both of those will give me the result that I need. I think what we actually chose to do was halve both of them last week. We actually adjusted both of those, but in the simplest case, I might decide to put twice as much in and stick with 100. And I can verify there that 4 and then 4 zeros, 2 2s are 4 and 4 zeros. So I know that C1 V1 equals C2 V2. And that gets those done, and then it's just a matter of figuring out the last one. And the last one, we're just going down to a half the stock solution, so it's a 2-to-1 dilution. So providing that I make V2 twice as large as V1, I'm going to achieve the result that I need. So in this case, well, what we chose to do is use a 5 ml pipette, and as long as I doubled that, it would give me the 2,000 down to 1,001 dilution. So just keep those proportions in mind when you're building your dilution tables. I think that's the best way to approach these things.